So good afternoon, everyone. My name is Ms. Rodriguez, and today we're going to be talking about density and how we demonstrate density. But before we get started, I have a few questions for you guys that I want you to answer before we actually start our lesson. So I want you guys to take a few minutes, maybe grab a pencil or pen and a piece of paper to document your answers. And then once we're all done, we're just going to come back together and go over what we got. And if you guys don't know the answers, that's perfectly fine. This is just for practice first. And if you do, well then great, we're gonna go over it. And when you guys are done, maybe you can use the reactions in the Zoom chat to let me know when you're ready to move on. Awesome. So now we have question 2. How much stuff an object has in a unit of volume gives us the
Sorry, I forgot to use my reaction.
Oh, no, that's fine. Awesome. Great. Next question. If an object floats in water, then it is blank than water. All right. And we're just going to move right along. And this is going to be our last question for the warm-up. Which ball is more dense than the water? Awesome. All right, so now we're just going to briefly go over it, and you guys are going to share with me what you got. So we're going to go back to question 1. So question 1 said, if an object sinks in water, then it is blank than water. What did you guys get for this one?
More dense. Is that right? Or is it heavier? Oh, wait. If an object sinks in water, then it is. Oh, I don't know why I put C.
That's okay. But yeah, you guys are on the right track. So it was more dense than water.
Okay.
I put heavier.
That's okay. We're going to clarify those any confusions that we might have during the lesson.
Okay.
All right. So moving on to number 2, it said how much stuff an object has in a unit of volume gives us the, what did you guys get for this one?
Is it weight?
How about you, Wendy? What did you get?
Density.
Density. Okay, so good job to you, Wendy and Allison. The correct answer here was density. But I'm so glad that you brought that up because we're going to clarify that confusion that we might have with the weight and density during the lesson. All right. So number 3, if an object floats in water, then it is blank than water. What'd you guys get?
Lighter.
Yeah, I put lighter, but now I'm thinking since we're talking about density, it's probably C.
Yeah, awesome. So I can see where you guys might have gotten just a little confused on there. But right here, we're going to be talking more about the vocab during our lesson. So you guys are doing awesome. All right. And number 4, we have which ball is more dense than the water?
I put ball B.
I put
ball A. Sorry.
Yeah, I put ball A.
Yeah, D.
So you guys both got that right. Okay. You guys did great on the post test. So now we can start our lesson. So like we mentioned before, we're going to be talking about density, but what exactly is density? So density is basically the measurement of matter inside an object per its unit. So this can be determined if the matter is tightly or loosely packed. So you guys can go ahead and do that with me if it's tightly or loosely packed. So if we look at this picture right here on our right, we can see that object B has a greater density because there's more tightness compacted into that one box. Yep, that's just right. So in order to help us determine what density is, we kind of have to know what's actually inside that. Because what do we mean by when we say matter in an object? So now we have what is mass. So mass is the amount of matter in an object, meaning how much stuff is contained in each object. So as we did over the pre-test, I saw that a few guys got a little confused on what was the difference between weight and matter or density. So we got to remember that mass of an object always stays the same, while weight is adding any force down on our surroundings at a given location. So if we take a look at this picture right here at the bottom right, mass is what's inside the object, but weight is acting downwards, so meaning it's got a gravity pull on it, which is making it heavier. So our mass will always stay the same. Meanwhile, our weight can change depending on where we're at. So if mass is how much stuff is inside of an object, how are we supposed to measure it? So next we have what is volume. So volume is the total amount of how much space is taken up by this matter. So if we go back right here, we can see that this is how much of something is inside of an object. And volume is telling us, okay, well, this something is taking up this amount. So similar to how you guys are sitting in a room, you're taking up a portion of the room. So it's really just calculating how much is it being taken up in a given space. So this picture right here on the right can kind of show you guys what this means. There's liquid in this glass, or water in this case, and the water's volume is the amount of space it's taking up inside of our glass. So everything has volume, but how are we supposed to tie these things in together? Why am I telling you guys density, mass, and volume? So why I'm telling you guys this is because everything correlates together. And when we go to the next part of the lesson, we see solubility. So solubility is basically the ability of a substance to dissolve, especially in liquids. So a substance that is dissolving into the solvent is called the solute. So water is usually the first thing that we think of when we think of a solvent and we mix something together. So we can refer back to density. That's how tightly or how loosely something's inside of an object. Matter is how much stuff is contained inside this object. Volume is how much space is being taken up. And solubility is the ability to dissolve inside of a given liquid. Awesome. So when we think of solubility, there are some things that are soluble and some things that are not soluble. So what are a few of these things? So we're going to do this together. So here we have a T-chart, and I have soluble on the left and insoluble on the right, and a few pictures that I want you guys to help me kind of categorize. So when we think of oil and we think of pouring oil and water together, what do you think is going to happen during this process? So let's say,
I was gonna say, I don't think they mix because, like car oil, like that's been like dropping from like a car, it's like on top of like puddles, like when it rains. So I don't think.
I think it's too thick to mix.
right, so you guys are saying that the two are not going to mix, because when we think about it, when we go back to density, then we think it's how tightly or how loosely something is together. So oil is less dense than water. And how Allison said when she thinks of oil pouring on top of a liquid, it's going to flow So meaning oil is less dense than our liquids. So since we said it's not going to dissolve in our liquids, that means it's an insoluble, because the two are just going to separate or stack on top of each other. They're never going to dissolve in one another, because no matter how many times we stir it, it's just not going to correlate with one another. So now we have salt. So let's think of a time where you had a toothache at the doctor. Usually the doctor tells you to gurgle what to make you feel better.
Salt water.
Right, salt water. So when we combine water and salt together, we can see that most of the time we don't have anything left at the very bottom of the cup, because after we stir it, we can see that, yes, it's added to the water and the densities are changing, but we can't visibly see it like how we would with oil. So would salt go under soluble or insoluble?
Soluble.
Soluble, right. So we're going to move that on over. So next we have sand. So same thing here. Sand is typically heavier, and it usually sinks down to the bottom when we have a liquid. So if it sinks, that means the density is higher or lower?
Higher.
Higher, right, because it's heavier, so it's acting downwards on it, and it can't dissolve in the water or any kind of liquid for that matter. So would it be a soluble or an insoluble?
Insoluble.
Insoluble, right. So we can drag that on to the side. And last one we have is sugar. So sugar, when we combine it with the liquid and we give it a stir, is it similar to sand where it sinks, or salt when it dissolves?
It's like salt.
Right, it's like salt, because even though we're changing the density and it's getting a little heavier inside the liquid, it still makes it look like it disappears, but really it's still inside of our liquids. So it makes it a soluble. So you guys did great on the T-chart. So now this is going to take a little time, but now I want us to move into testing out our density in salt water. So I'm going to move to a different station, and while I'm moving, I'm going to have you guys get your cups and materials ready. Okay, awesome. So I'm going to point this down just a little more. So in this experiment, we're going to really be testing out the density of salt water and how it changes depending on how much of a solution we add to each, or how much of a substance we add to each solution. So what I want you guys to do is gather 6 clear cups with 1 cup of water in each. If you guys need time to fill that, you can go ahead and do that now. So the next step that we're going to do once we're all ready is we want to get our salt and a teaspoon for measuring. So we want to get 1 teaspoon and just some salt. Awesome. And are we ready for the next step with our salt?
Yes.
Yes.
Yes, awesome. Okay. For this next part, I want you guys to kind of keep it in order. Which one's going to be your 1? So this one's going to be my 1, my 2, my 3, 4, and the ones closer to me is 5 and 6. So for our first cup, what we're going to want to do is take some salt and measure out 1 teaspoon and pour that into our first cup. And once you have your first cup finished, we're going to go ahead and take 2 teaspoons and add it to our second cup. And as we continue to move along, it's going to go based on the number. So the first cup had 1 teaspoon of salt. The second one is going to have 2, third one 3, fourth one 4, fifth one 5, and sixth one 6. So let's go ahead and do that.
Are we mixing it? I gotta ask before I did it.
Yes, after you guys have added your salt to your cups, I want you guys to go ahead and just grab a spoon or grab your straw and go ahead and mix.
I like the more salt it is, like the harder it is to mix.
Right, and that's an important part of our experiment because as we're adding this, we can see that the color is changing because so has the density. We're gonna go ahead and test that just to be sure. So once we have everything mixed, we're gonna wanna take our food drops or our food gel and go ahead and add red into our first cup.
But if it doesn't, if it's not like mixing everything all the way, we still put in the food gel?
So we can spend a little more time mixing. I know it takes a little while. But just until you can't really see the salts anymore, then we're good to add food gel. But if it doesn't, that's okay too.
That has to be completely dissolved.
No, it doesn't have to be 100% dissolved. Just get it as close as you guys can. It'll be fine.
So the first one is supposed to be red.
So let's go ahead and add red to our first cup. And it might need a few squeezes to it. So let's go ahead and add maybe about 4 squeezes to our first cup. And Wendy, you might need a little more than 4 drops, just so the color appears better. And we'll test it out on just a moment. And for our next cup, we're going to want to make the color orange. So we're going to want to combine yellow and red. Give that a stir.
Stop. Sorry. Orange.
Are we doing like Roy G. Biv?
Yes, exactly. That's a good way to remember it too. Like So by Roy G. Biv with all of our colors.
So is the next one yellow then?
Yes, ma'am. Next one is going to be yellow.
I feel like a little mini tornado in my cup.
And then number 4, the cup color should be green. Fifth cup, we're going to add blue. So as we're stirring, what have you guys noticed that happened to the salt when we stirred it with the water?
You mean before we put the colors in or like after?
Yeah, so before we kind of put the colors in, as we were doing the experiment, what did you guys notice when we stirred? And even with the colors?
I mean, it was harder to stir like the more salt that was in there, and you saw
Yeah.
more particles like moving around.
And so it became a little harder and the salt was dissolving because it's soluble, right? Good observation. Thank you, Allison.
Is the next one blue?
Is it? Yeah, it's green and then blue. And after blue, is it purple?
Yes, ma'am. So then for this one, we're gonna add red and blue. And once we have that in there, we're gonna give it a stir.
I thought the purple was gonna be prettier. It doesn't look very pretty.
Great. So once we got all the colors, this is the part where we're gonna take our straw and just to test it before we actually do the experiment, I want you guys to take your plastic straw and dump it into your first cup. Hold your thumb over the top of the straw so you can capture it kind of like a syringe. And if you guys can see the color really good, just like that, then we're ready to move on. So it shouldn't be too clear. Just in case, we can go ahead and test the other ones. So you should be able to see that food coloring as we keep going along. See, like mine, I think I need to add just a little bit of more red into the purple. Okay. So did you guys get a chance to test out all of your colors?
Yes.
Awesome. Okay, so now we're going to go back to our first cup, which is going to be our red. And just a tad, we're going to dip the tip in. And again, hold our thumb over the other end of the straw so it captures some of that substance. And it should look something like this. And we want to make sure that we're keeping our thumb tightly on there so we don't lose any of that substance in our straw. Now I want you guys to move on to the second cup. We're going to dip it a little deeper, briefly release our thumb, and then capture it again.
Oh, okay. I got it.
Awesome. You guys ready to move to the next one?
Mm-hmm.
Awesome. So now we're going to move to our third cup, dip it in, release, and capture again. And then same thing with the fourth cup, dip, release, and capture. And it should look something like this right now.
Yeah.
Uh-oh, got on the screen. Oh, sorry guys, I'm gonna have to redo that. Dropped it on my screen. All right, and then moving right along. Let's move to our fifth cup. And then again, dip, release, and capture. And then when you guys are ready, the sixth cup, dip, release, and capture.
I'm hoping I don't drop it on my computer. Is that right? Does that look right?
Yes, that's perfect. All right. And Wendy, how are you doing?
Mine worked for the first till I got to green, and then after green, it didn't want to work anymore. So I'm starting over.
Yeah, no worries. Yeah, I know it can be a little tricky at first. Sorry.
I can do it, and then when I get to green, I only get a little bit of green, and then I get to blue, and then I don't get the blue.
If it helps too, you may want to grab your cup and kind of tilt it so your straw can go in a little deeper, because that might be the problem because the cups are kind of short.
Gotcha. Okay, let me try it again. But I do see the no.
And just let Wendy try one more time, and then we can dump it out and move on. But were you guys able to see the colors steadily rising in the straw?
Yes.
So we're going to talk about why that happened when we added the salt and the water together.
I see it now.
Awesome. Okay. So if we're done, we can go ahead and dump these out or just put them off to the side. Completely up to you. So we're just gonna
I'll move them to the side.
dump them. Move these two to the side. Okay. And then if you guys need to get back to a comfortable position, we can go ahead and do that now.
I'm ready.
So thank you guys for your patience and your participation during our activity. So now we're going to talk about why the liquids didn't mix together. Because if you guys could see, when we were actually putting the straw into each of our solutions, they were just stacking on top of one another. So why didn't they mix? So each solution had a different density. Because at the very beginning of our lesson, we talked about density can be different for all objects. It can either be tightly compacted or loosely compacted, depending on where we're putting our solution in. So as we added more salt to each cup with the same amount of water, the density inside each cup was increasing. So the volume of each solution remained the same, meaning the water, it remained the same for all 6 cups, but the mass of each unit was increasing. So basically everything that we were putting inside the cup. So in other words, there were more salt molecules tightly packed in each solution as we moved from red to purple. And this was for a future lesson that we can go over tomorrow. But for our next lesson, we're going to learn why the liquid stayed inside the straw as we kept jumping through the cups. Because usually when we release our thumb, the liquid just falls right out. But when we're dipping it, we could see that they just stayed inside. So we're going to go over that tomorrow. And for our vocabulary terms, we're going to grab our foldable that you guys took home yesterday. And it should look something like this with our density, mass, volume, and solubility. And then if you have tape or glue, either one will work. We're going to go ahead and open our foldable. And you guys are going to take your pictures that you cut out. So you should have one that looks like this. And then like this. The third one, which is a cup. And the fourth one, which looks like a beaker. So with density. So what is density? Again, density is the measurement of, can someone fill out that blank for me? And if you guys need the reference, we can look back at the slide.
Matter in an object.
Perfect. So its density is the measurement of matter, like Allison said, in an object of the unit. So we want to go ahead and take our image, which should be this one right here, and paste it on the left column next to density. And then we can fill out those little blanks. So when it's loosely packed, it has a lower density. And when it has a higher density, it's when it's compacted together. Density. So then the next one, it's going to be what is mass. And we're going to kind of work through this so we can do the post tests together. So what is mass? Mass is the amount of matter in an object. So we're going to fill in amount. And for our mass, we should have this image, because when we were talking about it earlier, it was how much of something is inside an object, and weight was the force down, just so we don't get those two confused. And then next we have what is volume. The volume is the total amount of how much space is taken up by the matter. And similar to our slide in our presentation, we should have the cup for this one. And we're going to go ahead and paste that. And what is solubility? Solubility is the ability of a substance to dissolve, especially in water. And last but not least, we have our last image, which is similar to our beakers, and it's showing the little particles have dissolved in our liquid. Perfect. Good job, Allison. Good job, Wendy. You guys did great. So you guys can go ahead and paste this in your notebooks. So when we keep going with our lesson, we have it to reference. So now we're going to go over what we've learned. And go ahead and take us to that. Nope, I already have it open. And here's the code. So whenever you guys are ready, we'll go ahead and get started. I'm wondering if it would be better if we stopped right here and then started up again at the Kahoot. Here we're going to stop.